Good afternoon, students. This is section 8.2, two-step equations today. We're just going to start going right into the problems that we have. And hopefully in class you remember the dating story that we had, because that's what I'm going to refer to when we do these problems. Our ultimate goal here is to solve for x and figure out what does x equal. What can I plug in for x in order to make these two sides balanced, to make the two equations balanced? Now, when we do this work, we ask ourselves the same questions. What am I solving for? I'm solving for x. And what's bothering it? 3 and 1. The question becomes, which one do I get rid of first? How do I know which number to do the inverse of first? And that's where our little dating story came into play. I have to extremely paraphrase this example that we had in order to make sure I have enough time to go through the questions. But really what it was is that these two numbers that are right next to each other, they're the dating couple. They're super close. They're holding hands. This guy here, he's further away. He's what we call the geeky friend. I need to get rid of the geeky friend first so that the dating couple doesn't feel embarrassed or shy or whatever the case might be. So the geeky friend in this case, circle the number and sign in front is a positive 1. What's the inverse or opposite of a positive 1? Well, it's a negative 1. Whatever I do to one side, I have to do to the other. These are going to cancel out, and it leaves me with a 3x on this side, and over here I have a 16. Now, I ask myself, what's bothering the x? In this case, it's the 3. And again, this is the dating couple. And like all dating couples, they divide. They're going to split up, especially in middle school. They're going to split up. So now I'm left with x equals 3 goes into 16 5 times with 1 left over. So my answer is x equals 5 1/3. I can always come over here and do my check and check my work to see if I got it right. What I'm going to do is plug it in, take this value of x and plug it into the original equation. So 3x plus 1 equals 17. If x is 5 1/3, I'm going to plug it in here for x. Whoops, wrong one. If x is 5 1/3, I'm going to plug it in for x and solve the problems. 3 times 5 1/3, well, I'm going to have to turn this into an improper first. 15 16 over 3 plus 1 equals 17. 3 times 16 thirds, well, these 3's are just going to cancel out, and it's going to leave me with 16 plus 1. And 16 plus 1 is 17. Does 17 equal 17? Yes, it does. My answer checks, so I know this is right. Okay. Whoa, I can't see my scrolling bar here. Excuse me while I move this a little bit. All right, so let's try another problem. Let's start with an easier problem here. 3x plus 2 equals 20. I'm going to draw my railroad tracks first, so I know that I have to solve for the side over here on the left. I want to solve for x. This is the dating couple. The 3 and the x are dating. So who's the geeky friend? In this case, the geeky friend is negative, or is a positive 2. The opposite or inverse of a positive 2 is negative 2. Whatever I do to one side, I have to do to the other. So I have to cancel these out, and I'm left with 3x on this side. And on this side, 20 minus 2, well, that is 18. Then, to solve for this, since these are multiplying, the inverse is to divide. So I'm going to divide both sides by 3, and I'm left with x equals 6. You can go back and do the check for this as well. Do it a time. I'm not going to do that because I would like to get as many examples in, but the answer here is 6. All right. That's a problem we did in class, so I'm going to switch it up a little bit, and I suggest that after I write this down, you hit pause and solve it, and then come back and see if you got the right answer as I work through it together. What I'm going to do is look at this. This is the dating couple. They're right next to each other. This is the geeky friend. The sign in front, there's not one, so I know that's a positive. And the inverse or opposite of a positive 6 is a negative 6. So I'm going to subtract 6 from both sides. These will cancel each other out, And I'm just going to drop this one down. It's a positive 3n. Negative 17 minus 6. Just to make sure I don't make any mistakes, I'm going to check over here. Sure enough, it's a tick-tock. So I have two negatives added together, so it's going to end up being a negative 23. These are multiplying because they're right next to each other, so the inverse is to divide. Divide both sides by a positive 3. The positive 3 is what's bothering n. After I'm done doing that, a bad thing happening to a good guy, well, that's bad. 3 goes in here 7 times with 2/3 left over. You may have had negative 7.6 repeating if you used a calculator, and that would be the same answer as well. Let's try another problem like this before we get into the fraction problems. 6 minus 3x equals 21. Once again, I'm going to draw my railroad track problems. And as I look at this, I'm going to look at this number. This number here is a positive 6. Remember, circle the number and sign in front. How do I undo a positive 6? Well, I subtract it. Whatever I do to one side, I do to the other. So I subtracted 6 from both sides. These cancel out, and this drops down. Now be careful what you see here. Don't be lazy. Don't miss. This negative sign has to come with it, because if I was to put a box around the term, remember I need the sign in front as well. When I complete this side, 21 minus 6 is 15. I still have to solve for x, so in order to do that, I notice that these are multiplying. X is being bothered by a negative 3 through multiplication. So to get rid of it, I'm going to divide by a negative 3. X equals positive divided by a negative is a negative. 15 divided by 3 is 5. So x equals negative 5. Again, I can go through and check to make sure I did that right, but I'm not going to right now for time. All right, in class, when we got to the fraction problems, I asked you to please just trust me. If you need to understand the mathematics, you can come back and ask me later. But I told you for a problem like this, if you have a variable, just shove it to the top. So when I do that, this is going to become 2x on top over 3. There are other ways of solving this, but I'm not going over those right now. So if mom, dad, brother, sister show you another way to solve a problem like this, don't say you're wrong, because they may not be wrong. They're just showing you a different way. And if you understand that way, go ahead and use it. So now I have the problem set up. I ask myself the same questions. Who's the geeky friend? Well, the geeky friend is going to be the one who's separated from the group, the one who's not close to the dating couple. Right here, this is really close. So this is my geeky friend way out here. But remember to circle the number and sign in front. When I do that, this turns out to be a positive 10. So to undo a positive 10, the inverse, I'm going to subtract 10. Whatever I do to one side, I need to do to the other. I subtract 10 from both sides, and I'm left with a negative 2x over 3 equals 52 minus 10 is 42. I still have more steps because I'm not done yet. So the next thing I ask myself is, okay, what's still bothering x? A negative 2 and a 3. How is this 3 bothering the x? Well, it's bothering it through division. So how do I undo that? I multiply. Multiply both sides by 3 will undo the division. Now I have a negative 2x over here, and over here I have 126. Still another step. Make sure you're showing all of your work. In order to do this now, what's bothering x? Well, the negative 2. How? By multiplying. Inverse, divide. So I'm going to divide both sides by a negative 2. Those are going to cancel out, leaving me with x equals 126 divided by negative 2. A good thing happening to a bad guy, well, that's bad. I don't want a bad guy to have good things happen to him. And this is going to be a 63. So negative 63. Once again, you can put it back in and check it out for yourself to make sure that it works out. Hopefully it does. Here's another example. I do not believe we got to this in all the hours in class. So if you need another example that we didn't do in class, here's one for you. N divided by -3 minus 2 equals -18. When I look at this problem, I ask myself the same questions. You're going to get tired of hearing me say it. What am I solving for? N. Who's the geeky friend? In this case, these two are really close to each other. The geeky friend is way out here. Circle the number and sign in front. The geeky friend is a -2. So to undo a -2, I need to add 2. I'm going to cross these out. They cancel out, and I'm left with n divided by -3. And on this side, -18 plus 2, 18 negatives and 2 positive is 16 negatives. Now I'm going to multiply both sides by -3. N equals a negative times a negative is a positive, and 16 times 3 is 48. There's your final answer for that one. All right, I'm going to go back and see if I can find another fraction problem for you. It might be on this page. Here it is. The big mistake on this problem, and you all made that same mistake in class, is that you're making assumptions and you're not showing your work. Make sure you slow down and show all of your work for your problems. You look here and you notice that this was right next to that and they're dating, and that this is the geeky friend. So a lot of you got rid of the +3, which is the right thing to do. Or got rid of the -3 by making it a positive, I apologize. So I added 3 to both sides, and I end up with a 28 on this side, and 1/4 n over here. But just like we talked about before, we're going to shove the n to the top, so it's like 1 n over 4. So everyone was telling me, well, it's 7. It's 7, because 7 and 4 make 28. But you need to slow down, because this does not say 7 times 4. This would be 7 divided by 4. And surely you can't tell me that 7 divided by 4 is 28. Ask yourself the same questions. What am I solving for and what's bothering it? The 1 and the 4. How is the 4 bothering it? By dividing. What's the inverse? Multiply. So I'm going to multiply both sides by 4. This is going to cancel out, and it leaves me with just a 1n. 4 times 28 is going to leave me with 8, 9, 10, 11, 112. From here, technically we divide by 1, but is that going to change anything? Dividing by 1, does that change anything? No, because it's going to give me the same answer. So my answer here is 112. I believe I have, might be a different page. There we go. Okay, we have one more variety to go through. We did that one in class in every single hour, so I'm going to skip down to a different one that we did not do in the hours. And it's right here. When I look at a problem like this, 10 equals 2a plus 13 minus a. I need to think back to section 8.1, what we did last week. And what we did last week is we looked at this and said, okay, what are my like terms? And we put shapes around them. I'll put a triangle around all the a's and a circle around all the numbers. And then I combined them. So I look here, I have 2 a's minus an a. 2 a's minus 1a is 1a. The 13 can't be combined because it's a different shape, so I'm going to put it down here. The difference is now I have a railroad track problem. Who's the geeky friend? Who's the one who's further away? It's this 13. What kind of 13? Positive. How do I get rid of it? Make it negative. Whatever I do to one side, I have to do to the other. So now I have a positive 10 minus 13. 10 positive, 13 negatives. Negatives are going to win by 3. Again, I could divide by 1 here, but it's going to give me the same answer because dividing by 1 doesn't change anything. Continue to ask yourself those same questions over and over and over again. Ask yourself the questions, what am I solving for? Who's the geeky friend, if there is any? How do I undo it? And then solve it from there. All right, good luck with your homework assignment, and we will see you in class the next day.